So for the first one here, we need to find three things. We need to find angle A up here, side little b, and side little c. Angle A is pretty simple. How do I find that? Perfect. 180 minus 90 and 26 together. Now, since we know this one's going to be 90, we can just 180 minus 90 is 90. So we know 90 minus the 26 is going to give us this one, which is 64 degrees. Now, to find B, I'm going to use the angle I was given, the 26. I could use the other one, but I like going back to information I was given so I know it's correct. B, according to that angle, 26 degrees, what side is B? That's the opposite leg. I know I have to find a side that I know, so the side that I know is 8, which is which side? The adjacent. So if I look at my definitions, opposite and adjacent make tangent. So I write out my definition of tangent. Tangent to theta equals opposite over adjacent. Now I'm going to plug in what I know. Do I know the angle? 26 degrees. Very good. Do I know the opposite side? That is B. That's what I'm looking for. The adjacent side. 8 inches. Now I am looking for a side. I have the angle. So what I'm going to do is I'm going to make that into a proportion by putting it over 1. So now I have the sine of 26 degrees times 8 divided by 1. Sine 26, I got to make sure I close my parentheses, times 8 divided by 1 is 3.507. Did I put in the wrong thing? I did sine, didn't I? Good catch. Tangent 26 times 8 divided by 1. 3.902. So B is 3.902 inches. Now to find C, I could do A squared plus B squared equals C squared with the 8 and the 3.902. But that would require me to use something I just calculated. There are two issues with this number here. First issue is I just calculated. I'm not sure it's correct. I mean, I'm pretty sure it's correct, but there's a chance I made a mistake. I may have just hit the wrong button on the calculator, like hitting sine instead of tangent. At the very least, even if I did everything perfectly, I've rounded that number off. And I don't want to, if I can possibly avoid it, I don't want to use a rounded number to do another calculation. So to find C, I'm going to go back to stuff I was given again, which is the 8 inches. Well, C is which side of this triangle? Careful. It is the hypotenuse. It's adjacent to the angle, but it is the hypotenuse. So we have the hypotenuse is what we're looking for, and we have the adjacent side. That makes up cosine. Cosine of theta is adjacent over hypotenuse. So I put in the information. I've got the angle of 26 degrees. The adjacent side is the 8, and the hypotenuse is side C, what we're looking for. I put that over 1. And now I cross multiply. It's 1 times 8 divided by the cosine of 26. 1 times 8 divided by the cosine. Oops, clear that out. 1 times 8 divided by the cosine of 26. 8.901 inches. So I now have all 3 sides and all the angles. So if I'm given an angle, like I did in this one, the second angle is easy to find just because of the angle sum, and then I use the trig functions to find the missing sides. When I'm looking for a missing side, I put in the angle, then I make it a proportion by putting that trig function over 1, so I can cross multiply and divide. For number 2 here, we are not given any sides, or we're not given any angles, we're given sides. The only angle we're given is the right angle. To find this side here, I'm going to use a squared minus b squared equals c squared. Why did I do 32 squared minus 14 squared? Yes, the 32 is the hypotenuse, and I'm looking for a leg. Very good. So I'm going to do second square root, 32 squared minus 14 squared. 28.775 millimeters. Now for angles, let's look for angle A here first. If I'm looking for angle A, 32 is which side of that triangle? This is the hypotenuse. 14, I'm looking for A, 14 would be the adjacent side. What trig function deals with opposite and adjacent? Cosine. Or not opposite, adjacent hypotenuse, I should say. You got it right, it's cosine. So cosine theta is adjacent over hypotenuse, and we plug in what we know. We don't know the angle. We know the adjacent side is 14, the hypotenuse is 32. Now, over here, I knew the angles and I was looking for missing sides. This one's different. I know the sides and I'm looking for a missing angle. So to solve that one, I use an inverse trig function. This is the cosine, so I'm going to use an inverse cosine. The cosine and inverse cosine cancel out, leaving me with angle. Actually, I'm looking for angle A, so I'm going to put angle A in there. The inverse cosine of 14 divided by 32 is 64.06 degrees. So this is 64.06 degrees. Now at this point, I could just subtract from 90 to get angle B up here. But just to practice, from angle, if I'm looking at angle B here, this is still the hypotenuse, but this side now becomes what? That's the opposite side now, because I'm looking at this other angle. Opposite hypotenuse make sine theta is opposite side over hypotenuse. So I'm going to plug in my information. Sine angle B equals 14 over 32. Notice it's the same numbers, just a different trig function. So now we have to do an inverse sine. Second sine, 14 divided by 32. 25.94 degrees. So 25.94 degrees goes up there for angle B. And I should note, if I add those two angles together, along with the 90, I do get my angle sum of 180 degrees. Over here, so I can rather quickly find angle B by doing what? Perfect. 180 minus 90 is 90. 90 minus 54 is 36 degrees. This is side A over here and side B. Remember, the sides are labeled for the angle they are opposite. This side here is across from this angle, so that is side A. This side here is across from this angle, so that's side B. Using my given angle of 54 degrees, B is which leg? Adjacent, because it touches the angle. That would make A opposite, and the 40 is my hypotenuse. It's across from the right angle. So I know the hypotenuse. I need to pick one to find. Let's say I'm trying to find B. So I've got adjacent and hypotenuse, which is going to be cosine theta is adjacent over hypotenuse. So I put in my angle 54 degrees. Adjacent is B, hypotenuse is 40. Am I looking for an angle or a side? Side. So I'm going to make this a proportion, put it over 1. So cosine of 54 degrees times 40. Divided by 1. 23.511. So this is 23.511 millimeters. A. If I'm looking at angle A, I have the hypotenuse, and A is the opposite. That would be sine is opposite over hypotenuse. So I'm going to put in sine of 54 equals opposite side is A. My hypotenuse is the 40. Make it a proportion so I can cross multiply and divide. Sine of 54. Again, most of you will have to close your parentheses. Times 40 divided by 1. 32.361. Now, I want to make sure these all make sense. So let's take a peek at what's going on here. And what I mean by making sense, I want to make sure I didn't make any stupid mistakes. Remember, the largest side is always opposite the largest angle. Well, the largest angle in any of these is going to be the right angle. So is the hypotenuse the largest side of that triangle? Yes. Here's the right angle. 32 is the hypotenuse. Is that the largest side? Yes. Here's the right angle. 40 is the hypotenuse. Is that the largest side? Okay, very good. Next, I want to make sure the smallest side is always opposite the smallest angle. Here's the smallest angle. Is that the smallest side? Yep. Here's the smallest angle. Its opposite side is the 14. Is that the smallest side? Here's my smallest angle. Opposite side is the 23.511. Is that the smallest side? Okay. That doesn't guarantee we're right. It just keeps us from making any really silly mistakes. Any questions? I'm going to make this easier on myself. Okay, let's see here. Probably. It's an offset V-block, so you can get closer to a vertical surface. Here's what I want to know. I want to know, looks like I give you a radius on this thing, don't I? Oh, let's say the radius of that equals 35 millimeters. I want to know the height from, I'll give you one more dimension here. From the bottom of the ground to the top of that, I'll give you the height from the bottom of the block to the V is 70 millimeters. Well, there are a couple of things I've got to figure out here. One of them, I need to know what's the full height of the V block. They're saying figure out what's the full height. They don't necessarily have to know it. I can do that here. Now it looks like I don't know any angles here, but I do. If I take the center of this circle down to the V there, remember what we have here is these are tangents. That means, one, that they make 90-degree angles there. Two, if I connect the center of my circle to where the two tangents intersect, it cuts this angle in half. So in other words, each of those angles is 25 degrees. Now, another thing that we have in any figure, any drawing, is all horizontal dimensions are parallel, and all vertical dimensions are parallel. So that means this line and this line are parallel because those are both verticals. This one I know is vertical because I drew it in to be a vertical. This one, as long as this V is a symmetrical V, it's not offset or anything like that. I mean, it's offset by where it is on top up here, but it's not offset as far as being crooked. It is a straight down V that has to be vertical. So that means if this is 25 degrees here, this angle here is 25 degrees. Now, another way we could have looked at that is a horizontal dimension and a vertical dimension are always forming right angles, which means there's a right angle there. So if that's 25, this here has to be 65, right? Either way, we have that information. Now, what's this dimension right here have to be? Well, I can find the dimension all the way across the V block up here. I've got 24 and 40, make 64 millimeters. I subtract that from the 148, gives us 84 millimeters total. Again, we assume that V block is symmetrical. That makes this here 42 millimeters. That's just half of the 84. If that's 42 millimeters, we have this triangle. I am looking for this height here. What's that height? How do I find it? Well, this side is going to be what side of the triangle? Opposite. The 42 is the adjacent. That makes a tangent. Tangent is opposite over adjacent. So I plug in my 65 degrees. Opposite side's what I'm looking for. My adjacent is 42. Put this over 1 so I can cross multiply and divide. Tangent to 65 times 42 divided by 1 is 90.07 millimeters. Which makes that whole height 70 plus 90 is 160.07 millimeters. Is the height of that whole block. Now let's focus back in on the circle here, the round stock sitting in our V block. I know two dimensions. I'm actually going to look at this triangle right here. In that triangle, I know two pieces. I know that this is 35 millimeters because it is a radius of that circle. I know this angle here is the 25 degrees. The dimension I care about is that dimension right there, from the bottom of the V up to the center of the circle. Now the angle I have is the 25 degrees. This missing side here is what side of the triangle? It is the hypotenuse. Doesn't matter what angle we're looking at, that's always the hypotenuse. If I'm looking at the 25 degrees, the 35 is the opposite, which is what trig function? Sine theta is opposite of hypotenuse. So we plug in our 25 degrees. Opposite side is 35, and we're looking for the hypotenuse. Put this over 1, we cross, multiply, and divide. 1 times 35 divided by sine of 25. Is 82.82 millimeters. So that distance, 82.82 millimeters. Next, I need to get from the center of the circle up to the top. How far is that going to be? 35 millimeters. So what I have for total height here, I have three pieces. This piece here is the 70. That's what was given going from the bottom of the block to the bottom of the V. This piece here, from here to here, is the 82.82. That's just from the bottom of the V to the center of the circle. And then this piece here is 35. That's my radius. So I add those all up. And I get 187.82 millimeters, is that total height. So I guess that's actually what I was asking you to find, is that total height. So that would really be it right there. Most of the time what's being asked is how far does that round stock stick out of the top of the V block? I would find that by just subtracting the height of the V block, which is going to give us 27.75 millimeters. What do you think? So let's just do this. Pretend that V is symmetrical. If I give you this angle here is 40 degrees, and the radius of that circle up there is 60 millimeters. I want to find the distance from the bottom of the V to the top of the round stock. Now again, the way we're going to do that is we're going to do it in two steps. We're going to go from the center of the circle down to the bottom of the V. Then we're going to go from the center of the circle to the top of the circle. Well, we know that piece is how big? 60, just the radius of our circle. We have to look for right angles in these figures. There are two strategies to find right angles. The first one is look for things that have to be horizontal and vertical. They're going to be right angles to each other. Horizontal is always at a right angle to vertical. The second thing we look for is a radius of a circle to a tangent. And that's what we have here, is a radius and a tangent. What's this angle here have to be in green? 20, because it's always going to cut this angle in half. So what we have there is this triangle. Oops, that was not my better artwork. We know this side is 60 millimeters because it's still a radius of the circle. This is 20 degrees. We need this height. That's going to give us this piece here. What side of the triangle is that? The hypotenuse. We know which side of the triangle. The opposite. What trig function is that? Sine, opposite and hypotenuse make sine. So sine theta, opposite of hypotenuse. Notice I always write out the definition of the trig function once I figure out which function I'm going to use, because I'm doing two things there. One is I am double checking to make sure that what that trig function asks for is what I have. I have the opposite side and I have the hypotenuse. The second thing that does for me is now it gives me something to put my numbers into. I've just got the formula there, I'm just plugging them in. So sine, do I know the angle, theta? That's the 20 degrees. Do I know the opposite side? That's my 60 millimeters. Do I know my hypotenuse? No, that's what I'm looking for. Now I'm looking for one of the sides. I have the angle. So I'm going to make that into a proportion. So I put the trig function over 1 so that I can cross multiply and divide. 1 times 60 is 60 divided by the sine of 20. $175.43. So this is 175.43 millimeters. So there's one final step. What does it have to be? Yeah, add those two together. Gives me 235.43 millimeters. Now, we've only gone through that one type of problem. I'm going to give you some homework problems on a packet where there's a lot of other types of problems we have to go through yet. But we're going to take at least another day to go through these trig applications. If somebody wants to grab their last packet and make sure these pages are in it, or if I have to give you a new packet. Page 358 through 361. Oh, yeah, I thought it was. So on those problems in there, go through, for now, pick out the ones that are V-blocks or similar to V-blocks. Similar to V-blocks would be something like this. That's still a circle and a V. So it works just the same way the V-block does. So if you want to try those, see if you can figure those out. That's another type of problem you can work on.